Welcome back, Geo students. This is Mrs. Fallon. We're on page 238 of lesson 8.4. So we're in your student journals. What we're going to do is we're going to end, this is the last section of the unit. We're going to talk about some proportionality theorems and then kind of go through some examples, and then hopefully you'll have enough to be able to kind of do some work on your own. So remember, this is kind of a recap, but in the previous lessons we've done our similarity theorems where we've proven that triangles were similar, either using angle-angle, side-angle-side, or side-side-side. Now we're going to talk about some proportionality theorems. So the first one, 8.6, says, if a line parallel to one side of a triangle intersects the other two sides, then it divides the sides proportionally. So let me say that again. If a line that's parallel to one side of a triangle intersects the other two sides, then it divides the sides proportionally. So that means TU and QS are parallel. Then what that means is that this piece here and this piece here are proportionate. So R to T and then R to U, or R to T and T to Q is proportionate to R to U and U to S. So sometimes I think it's easier to think about it as like letters. So if these lines are parallel, and this line kind of intersects them, then this triangle is kind of divided, those pieces of the sides are divided proportionally. So A over B and C, or A over B and D over C. I kind of did that backwards, but that's okay. Let me give you an example of one that you might see. So let's draw a triangle here, and then let's try to draw something that's parallel. So those two sides are parallel. So this is W, X, Y, Z, and we'll make this V. All right, so let's say this is X, this is 12, this is 8, and this is 10. So what we have to be provided is that we know that those two sides are, or those two lines are parallel. Then we know that all of these pieces, those four pieces that are formed from those parallel lines, are going to be proportionate. So it would, if you start here, it would be 12 over X and then 8 over 10. So again, there's a few ways you could set this up. So I start here, over here, and then 8 over 10. You could have done X over 12 and 10 over 8. You could have done X over 10, 12 over 8. As long as you're comparing like the right piece with the right piece, it doesn't really matter. So I got 8X to equal 120. And so I would have X to equal 15. So that's what that triangle proportionality theorem. All right, so the converse of the triangle proportionality theorem basically states the exact opposite. If a line divides two sides of a triangle proportionally, then it's parallel to the third side. So, if this line divides, if this is 5 to 10 and this is 2 to 4, if we can prove that those are proportionate, then what that tells us is that TU has to be parallel to QS. So again, I'll give you an example of what that would look like if you were gonna do this, like if this were on like Big Ideas or something. Let's say I had a triangle, I have P, Q, R, S, and we'll use N. And then I was giving you some side lengths. So 35, 25, 28, and 20. So again, you have to show that these are, what we're trying to show is, is PS parallel to QR. So again, set up your proportion. So you could do 35 over 25 has to equal 28 over 20. Again, there's multiple ways to set that up, right? So I'm going to go ahead and show that these are similar. I'm going to go ahead and cross multiply. And so again, there's a little leeway here as well about how you show. So I do it this way. So I just cross multiply, and then I show that I get the same thing both directions. You could reduce this fraction and reduce that fraction and show that they're equal. So there's a couple different ways you can do this. All right, so now that we've showed that those are proportional, we can say yes, PS is parallel to QR. All right, let's turn the page. Let's do the next theorem, which talks about three lines parallel theorem. if three parallel lines intersect two transversals, then they divide the transversals proportionally. All right, so remember, the L and M are your transversals. So we have three parallel lines. And so basically what it's saying is like this piece to this piece is equal or proportionate to this piece to this piece. Okay, so like those pieces in here and these pieces in here. Very similar to the last one, except we're not really talking about, well, number one, we have three parallel lines, and this is also not a triangle, okay? So again, an example of what you might see, you'd be given a couple transversals, you'd be given three parallel lines. So I have to show that they're parallel. We'll call them, I don't know, L, M, and K. I'm going to show you that this side here is 20, this side is X, this side is 60, and this side is 100. So if three parallel lines intersect two transversals, then they divide the transversals proportionally. So since all three of these lines are parallel, they divide my two transversals. So that means those four values are proportionate. So I could go 20 over X, and then 60 over 100. And then cross multiply. Oops, I did that wrong. 20, I get that. So then 2,000 divided by 60 gives me about 33 1/3. Okay. All right, the next theorem. So there's a few of them on here, right? So this is the third one. This is called the angle bisector theorem. So again, we're kind of going back to a triangle this time. So if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. Okay, so again, here's kind of your scenario. You have to be given an angle bisector. And so if you're given an angle bisector, and you can show that those are indeed an angle bisector, then the sides here, so like this side, I'll just call it A and B, are proportionate to the sides of the original triangle. So like A to B is proportionate to C and D. Again, I think it's easier to kind of go through an example. I'm going to give you one that's a little bit more challenging, just so that we can practice it. All right, so you can draw this figure with me. So I'm just going to draw a triangle. I'm going to add in some markings as well as some, I'm going to say this is 10 over here. I'm going to show you that those two, that ray there, we'll call this A to D, is indeed an angle bisector because it bisects that angle. So you have to be kind of shown this information there. I'm going to say this. I'm going to say this whole side here is 30. So the reason I'm doing this is because this is a little bit higher level, right? So if I just said this is, I don't know, 2 and 10, and this is, 6 and 30, you could show that 2 over 10 is indeed equal to 6 over 30, right? Because this gives me 60, this gives me 60, that shows that they're proportionate. So this piece here and this piece have to be proportionate to this piece and this piece. This one's a little bit more complicated because I gave you this whole length here. I didn't tell you what these individual pieces are. So when you're given something like that, what you need to be able to do is rewrite the sides, like B to D and C to D, in relationship to 30. So for example, what you'd want to do is like pick a variable to represent one of your missing side lengths. So of course I'm going to pick X and I'm going to let that represent D to C. If X is D to C and this whole length is 30, what do we do to represent the length of B to D? So let me say that one more time. If D to C is X and the whole length here is 30, how do we represent B to D? If you don't know, think about it this way. Let's say this was 10 here, right? And I said this whole length is 30. What would you do to get to B to D? This is 10, this is 30. Wouldn't you just tell me, oh, it's 20, right? Because if this is 10 and this whole thing is 30, then this must be 20. Well, how you did that was you took this 30 and you subtracted off the 10, right? Well, that's how you're going to do this one. You're going to say, okay, well, I'm going to take 30 and I'm going to subtract off x. So the expression that represents b to d is 30 minus x, because you're taking the whole length and you're subtracting off this piece here. Now you can set up your proportion. So you can go 30 minus x over x, so here to here, is going to equal 10 to 16. So there are multiple ways you can set up these proportions. I could have done 10 over 30 minus x and then 16 over x. Could have gone the opposite direction. Again, what's important here is that you match up corresponding pieces. So I have 10x equals 16 times 30 minus x. I'm going to go ahead and distribute. So I get 480 minus 16x. I'm going to add 16x to both sides. I'm going to move this up here because I'm running out of room. So I get 26x equals 480. And then I'm going to divide both sides by 26 and get 18.46. So what this means is this length here, so it depends on what I asked you to find. A lot of times I'll ask you to find like B to D, or I'll ask you to find D to C. So if I asked you to find D to C, the answer would just be 18.46 because it's x. If I asked you to find B to D, you would have to take 30 and subtract 18.46, which would be 11.54. So again, just be careful what the question is asking you to do to be able to, kind of finish that out. So to be honest with you, that's kind of the overall gist of what we're trying to get at. There's not a whole lot more that we're asking you to do on these. So there's just 3 proportionality theorems. What I'd like you to do is practice these. And so again, I tried to do one that was a little bit more challenging here so that you could at least see it worked out once. We're going to save the extra practice for what we do in class. But if you want, I would go on to big ideas, practice some of these proportionality theorems and see if you can get them correct. Make sure you're showing work because that will be one of the requirements for your tests and quizzes. All right, bring any questions you have to class and I'll see you next time. Bye.